Thank you, Frederick.
How are you today? Are you good?
I'm good. I'm good. It's quite nice weather outside.
Yeah.
So,
So today we're going to look at spectrum view, and it's my bad. We have different products saying view or short or long, but it's related to one of the functions in our new generation of scopes, which has this digital down converter. So anybody in right now who can always, send some text, I will send something, say hello. Didn't I say something? Hello? Yeah, I did. Okay, so one of the key features of our new scope, and we're going to go through this in about a half an hour, is this, what's the difference between a frequency domain analysis on scope and a digital down converter. So there's an app note, I think it's in the link in the description below where you can download this white paper, but essentially it's to reduce data and to get rid of something. Oh, there's South Africa. Hello. Uh, so we go down it. I mean, you can look at this and we could go through this, but I think that this is kind of the nice part of this architecture. So we have signal conditioning. We have you have an ADC that spits up sample rates, and then we have the time decimator for the time domain, and then at the other end we have this what we call a digital down converter, and an acquisition memory. So if you look at this, from this side, this is the real beauty of enabling this. So if we go down a little bit, there was an example. I think we saw that this morning, and it should be here somewhere. It's kind of a long paper, but it's quite. I like this paper. I read it a few times, so it's worth for you to do that. Let's see. So this is again, example. So let's assume you have a center frequency around 900 megahertz, and one of the things you want to do is capture it. At the same time, you need to make sure that you have a resolution bandwidth. A resolution bandwidth is related to time, and then depending on what kind of windowing you're using, you need a bit extra. But we will run some experiments now. And Jukka, you know this. This is a tricky one to do, but it's 900
yeah,
megahertz
it is.
span
Yes.
100 kilohertz resolution, band 100, and I think then you go up this that a standard scope, any scope would need like 50, 60 million points to do this. 60 million points. Just remember 60 million points. But when we talk about the spectrum view, which is this one, uses the digital down converter. And what does a digital down converter actually do? The DDC, digital down converter, shifts the 900 megahertz to 0 hertz.
Yep.
So, the real benefit is really on the higher frequency. You don't need sample rate. And then you sample around this. So in this case, 50 kilohertz is the sample rate, and then you need to, signal. So it means that you go from some million points back to like 4,000 points.
Yep.
And if you think about this, there's a good and bad things about this. I don't know what the bad is, but I'm sure I can find it out. But I'm sure know what the good is. So should we start doing some experiment?
Yes, I think that's more easy to understand than going through the papers.
Yeah. So if you have any questions, just text it and we will show you. I hope everybody can see the screen clearly. So let's start with no signal. So I have a 50 ohm termination. So we will remove this one, and I will hopefully add channel 2 here. Put this into not 1 mega ohm and 50 ohm. So it's a good starting point. And we put this 100 millivolt position. It should be like, no, it should be like 50 something. Let's assume this is a good starting point. So this is a terminated input. There's nothing on the input. What do we see? So let's put on the math, and we should do an FFT. So this what what we would expect. Did somebody knows what I did wrong here? I didn't select the channel. The source should be channel 2. It's a tricky one. Okay, so this is what we see. And of course, we need a little bit more time, and we go a little bit more time, and go more time, and more time, and more time. Okay, you see something. This is the spurs. All scopes have spurs. It could be different, but this is what we see. We close that one, and we do the same thing with spectrum view. We turn this on, and there's a badge coming up for us controlling this one. In this case, we have a center frequency on 1 gig and a span 2 gig. If we want to see the spurs here, we'd actually do the same thing. I mean, go manual and just go down, 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 and here's the spurs. Of course, the spurs is further down, but essentially you always have some spurs. I haven't found any customer have thought that this is a tricky one. So you can any questions about that? There's spurs everywhere because there's ADC involved. There will be interleaving some other frequency fundamental.
Yeah, exactly. Yeah. No, I don't have any questions.
So
I'm trying to adjust the picture here. So
you can do that, and I will actually try to trick you. You don't know that, but I set up a test for you, and we can have a discussion right about this. Hopefully, yeah, So this is, the trace below is the time domain. The second one is the one that goes through the digital down converter, and I had set it to a center frequency of 750. And as you know, then DC is 750 megahertz.
Okay.
Yeah. And the top one is FFT. And the scaling should be the same, about the same. So I have in my lab here, and I have a 6 series scope and have a nice antenna. And let me see if I can just do a run for this one. I have so many windows open, so let me see if we can cap. So in this case, I'm not sure if you can see it, Jukka, but what is this over here? So we say that these are getting the same data. One is going from to the decimator to the time domain where we do the FFT, and the other one is going to digital down converter. Shouldn't these traces be the same?
Yeah, but what you are showing, I couldn't see what you are pointing. So.
Oh, let me see.
From spectrum view, or
I'm pointing
because
over here.
the picture is pumping up and down. So.
Yeah. So
okay. Now I can see it. Yes. Okay.
So if you look at this, I suddenly have something over here, which is not visible on the spectrum view.
Yes. Okay.
We can run it again to see if we can capture it again. Yeah, you see here, same thing. It's visible on the FFT. Anybody from the channel knows why is this? Why is that? What is this? And why is not visible over here? What is the catch? And I've been into this, and there's a formula, Jukka. There's a formula for this.
Okay.
But it's also related to when you kind of undersampling. So if you have, for me, I have an antenna, it's kind of wideband antenna, it gets all the frequencies in. And if some of the frequencies are undersampled, they will show up as like an image or something. And you can calculate the frequency. Should we try that to see where actually the frequency should be? So
let's do that.
So I go in with the cursor. Oh, with the wrong one. I can turn those cursors off. I will go in with cursors off. I'll highlight this one and cursors off. And I will just drag this one around here. 611 megahertz.
Okay, 611.
Yeah, because if I go with the cursors down here and move cursors here, I'm not sure it's 611. There's nothing.
Yeah, there's nothing.
So do you remember how you calculated that to find out which frequency causing this for the FFT side?
No, can you?
Yeah.
Can you say that?
Yeah, it's very simple. This is simple. Take this one, which is 611 megahertz. You have a calculator. Somebody has a calculator. 611 minus the sample rate 3125. That should give us a good indication where this signal should be at.
What was it? 31225.
3125 minus 611. That should give us,
Yeah, it's 2514.
so 2514. So we set this to, was it 2514? Oh,
Yes.
2514 and enter, and we have the same span, and I do it again. Let's see. Yeah. So we have it again here, and here's the signal.
Yeah, okay.
It's not exactly
So that's
2514, but I didn't. So this is one of the things that you never have to really care about when you do measurement in spectrum view.
Yep.
So if there's a high frequency content hiding somewhere, you would then be able to what would I would say? You would be able to
what? Calculate.
calculate it. So this is
Yep.
one of the things. I mean, and how can I get rid of it? And again, it's very simple. You need to increase the sample rate. So if I increase the sample rate one step up to 6.25 and I run this one, of course it was not. Now I have it here, but there's nothing
Yep.
around 600. So it's related to undersampling.
Okay, so basically you were undersampling the signal.
Yeah. So if you think about this, when we talked in the beginning of memory is one of the, it's cheaper today and processing power is faster. But if we were to look at something, we're suddenly going to use a lot of data to be able to do it. So let's take this one. I go and I will just remove this spectrum view. So we just have the FFT.
Okay.
And I will turn this cursor off. So one of the things we said in the beginning, I will come back to that, is that, the ability of the spectrum views to kind of drag along and look at changes over time. We can do that with FFT as well. The thing is that if you have a lot of memory, it's going to be slow.
Yeah.
So we go up here and let's do like 2.5 million points. Here we are. Okay, what do we see? We see a lot of things. And if I were eager, we're actually going to do it a little bit more. Let's do 12.5 million points. So, here we go. And you can see that there is actually some bursted content over here. Something that looks like a burst. It's not very easy. What you can do with the FFT is go in here in FFT settings and set that gating with cursors. And then you turn the cursors on and you can try to kind of isolate that one. So did you see what kind of burst? Did you see it? I can actually do that, do it linked.
Yeah, do it again.
So I move it out.
Yep.
I move it in. Move it out.
Okay.
Move it in. Maybe move it in over here.
Yeah, it's the same with all those bursts.
Yeah. But if you look at the FFT here, it's kind of a lot of frequency. This one, when it's out, there seems to be something around here, you see?
Yes, yeah.
So it's a little bit, and of course this is, we should have auto scale here because it's even worse. So if I look at this here, is this something over here or not? And then I move it over, I need to have the right one, and I move it over here. So you can actually gate the FFT or gated FFT, you can do it. The problem starts when you need to zoom in and you do stuff, because every time you change the time domain settings, you change the FFT settings. The good things with this one is that you can have up to you can have 8 gig bandwidth for the FFT, whereas the MSO6 have a maximum bandwidth, the modulation bandwidth of 2 gig. So if you look at this, and I turn this off, and I will do spectrum view instead. And where should we concentrate? We can concentrate on the band between 2 and 3.
Yeah, I think that's the best one.
Yeah, so
There
I turn
are
the cursor
some bursts in
so I go to
that area.
Yeah, between 2 and 3, and I set the center frequency to 2.5. And the 2 gig span. Okay, so we do the same thing again. So this is what we get, and now it's a little bit more visible. So
Yep.
instead of having those kind of cursors where we, when we, depending on the cursor, we will have the resolution, but I will actually set the resolution band from the beginning. And the resolution band will give me this little dot down here.
Yeah, and is that the spectrum time?
Yeah, so if I move this along, it's actually doing the same thing, but, not with cursors. So if I want to have it, larger or smaller, so if I want to have more time, I need to have a longer FFT size. So
Yep.
that means that, a lower resolution bandwidth, like 5 kilohertz, and that will be longer, yeah. And then I can move
Okay.
this along, and it's actually the same thing as we did before. But you can see that we have a signal around 2.5. We can see it seems to be present all the time, more or less. So one of the things that the FFT can't do, I would argue that this is something that FFT potentially can do, but we haven't really gone into some of the things that is really cool. And please, guys, ask questions. This is live, so I will show you anything you want. So if we were to look at this one in more detail, if this was of interest in detail, we could lower the span a little bit, so we're just looking at that portion. So if we go down a bit like this, it seems that we only have this one, and I will click and click and click. And you have the same thing down here, which seems to be the different. This is kind of LTE channels. You can see how they move.
Yes. Yeah.
So the question is the power level the same over this one? So we can add the functionality to kind of narrow down, go into details, and get more data out on the spectrum view. And this is not really possible with FFT. This is going to be a hassle. So if I look at magnitude, for example, and I select the magnitude to be log, and of course you can see that down here it's less power, and then it's kind of a steady power, and then it's breaking up because it changed. You see that changing a little bit.
So you are moving that spectrum time
Yeah,
all over the
yeah. So I'm going to do it just a new.
waveform, or
Yeah. So this one, this yellow part, and this is the time domain over here. This is linked together, so that gives me, roughly the FFT length.
okay.
So if we move this one, you can see that then there is nothing. There's a signal
there's nothing.
on.
And then it's on.
Yeah, and it's off, and then there's on. So these are kind of, for the LTE or for 4G. This is some sub carriers that is, it is. I'm going to turn this one off. So some of my customers asking, but I don't see what frequency. Why don't we display the frequency? You can do that with markers, but you just need to lower the threshold a little bit for them to do that.
Okay.
So this is interesting. That is a 2.518. Maybe we should look at this signal, only this signal.
Yeah, that's a good idea.
And I take this reference marker, which is red. This is the strongest signal. I will put it in center, and we do it again. So it's not here, and it's not here, and LT is popping up all over the places, but we're not getting that one. You see, it's only in the beginning.
Yep.
So if we were to capture on this one, forget about time domain. If we want to forget on this one, we need to zoom in a little bit further. We don't need 100 meg. So let's zoom in. How much do you think, like this? And we do it again. Oh my God. And there's something there, but there's nothing here. This is the next step of the beauty, because I can use what I call magnitude versus time of filtered power as a trigger source.
Okay.
Of course, this is a tricky one because it's a part of the pilot channel for LTE. But if we go in and just select the trigger here, I can select channel 1 analog, which is the time domain. But I can also, as I enable the magnitude versus time, I can trigger on the magnitude versus time.
Okay, that's
So if,
cool.
so if I run now, I just need to do two things, DC and normal mode, perfect. Then I just need to remove that down to a portion that you can see I trigger on one of the bursts now. Do it again, I
Yep.
trigger on the burst. And of course our example was probably not the absolute best because there's not much energy here. So let's go down further to 500 kilohertz. Let's hope that I will be able to trigger on it. Otherwise we go for something else.
Something,
Yeah.
but is that the
It's a
is
tricky.
that the
Yeah, it's a
oh
tricky one. It's a tricky one.
yeah.
Because the pilot channel is not always active. So anyway, I had a preset up we can look at. We can do the same stuff again. But what I'm saying is that we can just do this edge analog and just this is just looking at. But maybe there's something else. I mean, LT is kind of stupid. Let's go to 2.4 gig where we have VLAN because the way
Yeah,
it's set
that
up. So we go
that
to
should be easier. Yeah.
yeah 2.44. So let me see if I can capture some elusive 2.4 gig and I do a single. There is a VLAN burst, so let's move that in the middle. Let's assume that this is my VLAN. We probably don't need 50 megahertz is good. We go for the analog and we need to trigger on magnitude versus time. And let's see if we can trigger on it. I'm not sure about the power level.
Yeah, maybe you went down a little bit too much.
Yeah. So this is something that people often do. I do the same. Is I have the time domain over here and a trigger over here, but this is making sure that you have it over the trigger. So right
Yep.
now I'm triggering on this one, and we can actually see that the timing is not that. So if we run it again, we will have the next one, and you can see it's kind of bumping up and down, ding, 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 ding.
Yep.
But it's not perfectly in the middle, so you can always drag this in the middle to making sure that it's a little bit better. So this is a way to to trigger on single VLAN channels, for example, using a scope, because if you look at the time domain, that's not going to be that easy because I'm sure there's more things in this signal than just this one.
Yep. Yeah.
So that's why some people would like to have a more span, for example. Let's see if we can capture something. And the more span you have, so if you calculate the power, it's going to be tricky. And the more narrow you have, we need to move this a little bit down. The more narrow you have, you will be able to trigger on it, but you can't really see what it is. So it's basically kind of a nice tool, at least, to look at. So this is VLAN, and so I can drag this one to see this one, and then we had this one. Oh, do you see the difference here, Jukka?
Yes, definitely. But
And
that signal is behind you on the picture, so
oh, this one, this VLAN. So let's trigger on this. This is an awkward signal. This is most likely Bluetooth.
yeah, could be.
Yes.
It looks a little bit like that, yeah.
And I just need to make sure that, remember, this one in the middle. So if you have that
Okay.
centered around, this is a common mistake that centered around there. Here we go. Let's see again. Can I do it again? Oh, that is a part of VLAN, part of VLAN,
Yep.
part of VLAN, part of VLAN. Okay. So we need to make sure that when we trigger on this one, we have something here. So
Yes.
we have the time domain here, and then we have this one. And how long is this? This is probably the right power level is there, but it's probably like over 300 microseconds. So this is active more than 300 microseconds. So
Yep.
let's now go in and trigger, and let's trigger on the more than 300 microseconds. So we go edge with the pulse width. Pulses, blah, 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 trigger when it's over 300 microseconds. Enter. Okay, let's see if we can trigger. Oh, that's more because it's VLAN. Here you go. So maybe we should put it shorter than 400.
Yeah, maybe that's
Limit.
yeah, try that one.
Yeah, maybe
Because
that's.
now you are.
Here we go. I don't know
Okay.
this one. Yeah, I don't know this one. But that is a good one. So now when we trigger on this one, I'm actually selecting a single Bluetooth with my antenna open here. You know, what else could we do? Could we try to decode this one?
Yeah, that would be nice.
Yeah, so we go in here and go for a spectrum view, and I have some selection. I have a magnitude on, but let's put frequency on. Yeah, you see that we probably need to have a squelch.
Yep.
Because this is the thing I'm interested in. The rest is just garbage. So I go in here and we turn squelch on. Oh, that was too much. Maybe it's like 10 micro. Probably more than 10 micro. A little bit more. I go up. 14, 15, 16. Give it 20.
Yeah.
Maybe 30. Yeah, it's gone. Okay, so the garbage is gone. And
Yes.
then we probably need to increase it a little bit. And we do it again. Oh, can we get...
Yeah, but no.
And of course I don't get the... here we go.
Yeah, here we go. Good.
So I'm just wondering, because you know, it's not really clear to me, but I don't get the resolution really I want. I can't make sense of this one. It seems that it's in center frequency, but maybe all of this around this is disturbing. So maybe we should go a little bit, not 20 megahertz, but maybe like 2 megahertz. Should we try that one?
Yeah, try that one.
And
Okay.
I triggered on, I'm just making sure the trigger. And here we go. Yeah, now I can probably start
Yeah,
seeing
now it
things.
seems.
And we don't need that long time base. Yeah.
Okay.
So here
Wow.
the decoded data. So we do it again.
Yes.
Probably need to move the trigger a little bit. Move the trigger a little bit so we can get it like this.
Okay.
Oh no, 100 like this.
So there is definitely something in it.
Yeah. So Bluetooth is an FSK. So the
Yeah,
question
okay.
is now if we can decode this. So we go in and add new bus. And we treat it as a 2-3 source should be frequency versus time. This should be this one. Or did you see? I have a decoder.
Ah,
And I go to result table and bus decode and add. So we have 5509, yeah, 35 packets decoded. And we can look at this again. 55 is the start. It's always 55. That was a bad one. 01, 0, and 55. So this is a tricky way you can do it, you know, that you can use the spectrum view to navigate in the frequency domain. You can look at it and you have frequency and you have magnitude that you can use as a trigger source. And then I played around to decode this one a little bit.
so is this something that you can do with the FFT also?
I wouldn't even try.
Yes. Yeah, exactly.
I wouldn't even try. Because if you think about the fundamental reason why it's good to have a DDC, it's speed, because we're reducing the needed sample rate.
Yep.
Yeah. And if you think about sample rate, you know, it's going to be a mess. Especially have multi-channel. So one of the questions you asked me, what about if we have, no, I do a default setup. What if we have a scenario where I expect my 40 megahertz clock, which is lying on channel 3. I just do an AutoSat. That error is caused by something that is much higher in frequency.
Yep. So you have 40 megahertz clock.
And something, yeah, I'm just gonna do this.
Something, okay.
Yeah, and this one, just a 40 megahertz clock. Let's assume this is the starting point. So below is my 40 megahertz clock, and I can actually use that as a trigger. Channel 2. or channel 3.
Okay.
And for the sake of good, let's assume that we believe that this 40 megahertz clock is disturbed by something that is around 160 megahertz. So we do a normal math again, FFT, just to check. So we do an FFT on channel 1. Then we need to do an FFT
Okay.
on channel 3. This one is going to look at 2.4 gigs. So that one we're going to auto scale off from 2 gig to 3 gig. And this one we're not going to auto scale. That is interesting, from 20 megahertz, which is the clock is 20 megahertz.
Okay.
20 meg to 60 meg. I just put something. Okay. So this doesn't tell us anything, and this tell us something. So we need more data, yeah?
Yes.
So we need more data, and more data is giving us. I'm not happy yet.
Yeah, you need a lot of samples.
Yeah. And then when I stop this now, I'm still not happy. I need much more. And I need the sample rate to stay on. I need to affect record length. Just go up 2.5. And what you see what's happening at one point is that to get a very good resolution on this one and still be able to obtain, the Nyquist zone here, because I can't get too low. If I go lower and I'm sampler, I can actually try it. If I go to 3125, I mean, I don't even see that anymore. So I'm stuck. I'm stuck with the 6th one. And it's still not efficient resolution for me to do this. So there's probably like something here. And when you're going into this kind of several 100 million points, I mean, not everybody's even having the option. This is going to be very, very slow. Because there's so many million points we're going to run. So in sometimes it's much better to do it the other way. And you can see it doesn't really give you all the information. So this is what you can do with FFT. You can do it, but it's a lot of memory required.
Yes.
So remember, past in the days when we sold memory options. You did.
Yeah, I remember. Yes.
And you did that.
But at that time it was the basic memory was like kilopoints.
Yeah, but you did that for people that actually you wanted to do FFT. You could sell them to do that. So instead of doing this, we do a default step. We do the same thing with Spectrum View. So we have channel 1 and channel 3. I will go with this one, 50 ohm. This one I will auto set. And I need some tobacco as well. Any questions? No, nobody's have any question. We do the same thing again. We go back here, channel 2, channel 3 with trigger on this one, source add, blah, 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 and move it up. Okay. So, and this one is a little bit, we need to be a little bit bigger, like 5 minutes. Okay. So do the same thing again here. We have Spectrum View on. And I go with channel 3 and I have Spectrum View on.
Okay.
And then we're starting having, different, we can have them in the same window. Okay, so this is the starting point. And we said, channel 1 needs to be around 40 megahertz. So we don't want to lock it. Channel 1 should be around 40 meg. 40 meg. Good. We have a span of maybe 200 megahertz.
Yeah, looks good.
It looks good. Okay, I'm happy for you. And 3, we had this like 2.44 gig. Yeah. Oh, 2.44 gig. Enter. And there's nothing. We can actually have it a little bit. We can go a little bit more like 2. Doesn't really matter. So the question is now, you see it's kind of still very fast.
Yes.
and the time domain set is just running. We have one looking at one and one looking at another. And the thing is, I think I did the wrong way, because channel 3 should be at 40 megahertz. It was my bad. And channel 1 should be like 2.4 gig. My bad. So,
Okay.
so what they really share is the span. If you think about span, so that is the sample rate. So, to be able to do this, they need to have. But what we can do now is, think about this. We have a 5K resolution bandwidth, and we'll go down to 20K, 3K, 2K, 500K. This is gonna be. That's a long time.
Yeah, it takes.
But it just runs.
Yeah, exactly.
It just runs. So this is this is one of the most coolest stuff that you can do. It just runs. So if you have one of those with for example, a limited memory, the memory on the scope will set the actually usable bandwidth, resolution bandwidth, etc. And the sample rate will tell us the F max. So
Yes.
and nobody has any questions, and there's still like 30 people looking. Can we get one question? It must be the most boring. Yes, you can actually you don't have to show the time domain traces at all. And yes, if you go into the horizontal scale on the time domain, you can have it at manual, record length, and you can put any sample rate here. It doesn't really matter. So in some cases, it's actually faster if you go into the time domain setting, just because you don't use it. So this is one thing you could do.
Okay. Do we have any questions?
No, you need to ask a question. Can you save the data in some useful way?
Yeah. What would be the best way to save the data? Waveform?
You can see.
Yep.
You have
Now I can see.
Yeah,
It's,
yeah. You can save it as INQ, which is a big difference from FFT. It's hard to save as INQ.
yeah. So what is the other ones? There is a screen capture, setup, report, and session.
Yeah, screen capture, I think everybody knows. Waveform is waveform. But I'm saying here, waveform, depending on what you want to do, you can save the baseband IQ.
Okay.
You can save it a MAT or TIQ file. People who are using our TIQ files, like Spectrum View, can open it in Spectrum View.
Yep.
Setup, I don't use this too much. I tend to use this session instead. And reporting, as I have Windows option here, we can do a report here saying that we did a good job, and so we have the scope number, what probe I have, the measurement I have. I didn't have too much measurement. The good thing about it actually stores the scope serial number and calibration status.
So by pressing that, you get all the needed information for the report.
Yeah. So this is. Can we fantasize a little bit? So that some of these features came in late in terms of the triggering features. What do you believe will come Boxcar 11, 12, 13?
Are you asking me or from
the... Just guessing. I know this is
I don't know. Actually, there have been so many releases already that there is a lot of possibilities, lot of things that you can already do. So I'm not sure what is coming in the future.
Yeah,
do you have?
I have some ideas at least, but I don't know.
Ideas.
So it's like occupied bandwidth, some standard RF measurement that would be really nice.
Okay.
I would like that, and then there's a few things as well, like a Manchester decoding. That would be yeah, because then you can start to decode different devices, and you can do a lot of cool stuff with that. So I think it's probably on the wish list. But this is what I wanted to show. Nobody is asking any questions. I'm not sure if they can do that, but please ask a question and we go through it. But what I would like, after this session is understand that yes, we have FFT. You can go do a gated FFT. You can do all that stuff. Thing is that it requires memory, and most of the scopes today come with some kind of memory, but it's gonna be painful to run FFTs like I do now. We have two different center frequency and resolution at 1 kilohertz. In someone, can you make notes on display? Yes, you can make notes on display. Let me show you. It's called call out. Good. What should we call it? I can double tap and I call it a note text. 40 megahertz clock.
Can you change the position of that?
No, let's start by. I don't like that color. I would like.
Okay.
I would
Yeah.
like it to have it like this. Okay, and
That's
you can
good.
change your size. You can make it bold, italic, and underline if you want. Yeah. And you click on this one. You can move it around if you want to have it somewhere. This is really what we would like to measure. So there's note and arrow. Oh, it's not pointing the right way. Like 40 megahertz clock. Oh, 40 hex clock. I don't know what I put there.
Yeah, that's
You can have a rectangle like
megahex. Yeah.
you can put it over here. Look.
Okay.
And the coolest part is probably the bookmark. So the bookmark is actually added to somewhere. So let me see what it is. It should be channel 1 normal. And I'm just wondering where it is. It's yeah, it's on the time domain. So I need to open up the time domain. It's actually here. So this is where I can actually put it on a frequency, for example, there. And I have this one, it measures, So if I run this again, it will actually live measuring. It's kind of, should be able to measure.
Yeah.
Yeah. Can you make notes on display? Can you make any notes on display? You can do that. You make notes, you can do. But we call it call-outs. It's more like a note. So, for example, it was Arne asking, like, if you want to do that. Hi, guys. Hi. Found this error. Can you check? Can you check? So this is just, this is just a note. And you can put the note anywhere. You can put it over up here just to confuse everybody.
Yeah.
I actually did it, one time I did it like this. Secret menu, enter. And you put it over here.
Yeah, that's
And people get like, what's that secret menu? No, it's just a note. Let me see, I got some questions here. Can you use signal view on the scope? I think this is where we're going. We used to have signal view support on all our scopes, so I don't think that is an issue. I don't really know how they're going to implement it, but as we have already I and Q, I would say yes. How to monitor the mode of operation in hopping? Okay, so you want me to do some hopping? Should we do that? Should we?
Yes. Yeah, if you have a signal for that.
Okay, so should we do a test the hopper, frequency hopper radio? Let's do that. I need to. You can talk.
Okay.
Enjoy the guys while I'm changing the cable.
So what are you doing there? You are okay. Yeah, let's see what Frederick comes up with. I think he has a signal somewhere in his secret lab. I hope it doesn't take too long. So, yep, you found it? You found it?
Yeah, I found it. You can talk now. I need to set it up. This is going to be a little bit tricky.
No, you can show what you are doing. So
I'm not on one show.
You go for the auto set. But what is the signal? Where are you getting it?
From the demo board. We have a demo board, and which some of the customers can buy. I think is the MDO4 demo board.
Okay.
But we can do a default setup, so I don't have.
And you set up a hopping signal.
Yeah. I don't
Okay.
remember what frequency. So I have a BNC connector. What I need to do is put the termination to 50 ohm. Okay, let's start.
So if you don't remember the frequency, then it's more like now we are
Oh,
hunting that
no,
or
we don't. We need so, and we put this on. Normally, all the demo boards, etc., have around 2.4 gig because it's open band,
yes,
so it should be like the 2.4 or 2. I don't know. And this is what is it? 900 megahertz giga.
yes, that's good.
Yeah, that's
There's
good.
nothing on that.
Yeah, so I think here we are. There's some spurs from that
Yes.
card, but I think
Okay.
this is okay. So we need to go in a little bit, just to look at it, making sure. And this is a cool feature I use from time to time in Spectrum View. There is a max hold. So if you run the max hold, and if you're not sure about your hopper, just leave this for a while, and then you can actually measure, manual measure. But this is how it looks like when it hops. And what I'm trying to achieve is that I'm not, I'm
So
trying
then,
I try to see what we see. Yeah.
okay, but you can put a cursor and then check out if there is something that you really wanna dig in.
Yeah. So if I just
Okay.
I can add cursors here and I can do a lot of CM.
Okay.
But this is not, making just
Cool.
sure that I'm in the right band somewhere. So
Yep.
good. I go back here and that's the first one. So then I don't want to look at that. Then I would look like at, for example, frequency versus time. And if I stop this one, you can just see a line, yeah? Just a
Yep.
kind of a line. What we need to do is, we need more time. So we do that again. You can start seeing things, yeah?
Yeah, there is something
Yeah.
something going on.
Something
Yeah.
going on. And you can use this for the same thing. As long as I check that the center frequency are right, now the frequency are hopping. And you can go, double click here, you can have persistence infinite. And this is another way of looking at things. But the problem is now I'm not really triggered. It's going to be all over the place. But I will see some details. The second thing will be to trigger. So in this
Okay.
case, it would be nice to trigger on frequency, and I will do that. So I go up here on the edge, and I have selection of analog or frequency versus. I'll just put frequency versus time. So this gives
Okay.
me something. And what do we see here? Yeah, we can see some trends. We have some odd ones over here. If I move this one, it's like 0 now. I can move it down. Or I can move it up. I can actually move it to the top. And as long as as long as I have what I call a stable trigger, I mean, there's different ways of doing that. There's a timeout triggering. There's 3 different triggers, but it's timeout, it's putting in the width, or just rising or falling. So I'm triggering at the rising edge at 6.74 megahertz right now. But this I would say is a stable trigger, stable enough.
Yep. Yep.
So let's hope it's stable, because it's not. And I go for auto again. And all I need to do now is getting a little bit more timeout. And then you can start seeing these kind of odd behaviors, you see?
Yeah.
And this is probably, and you can see that these are much higher than this one.
Yeah, exactly.
So
It's a little bit blurry, but I can see
yeah,
that.
it is. So we look at a peak to peak cyclic.
Okay.
Let's see that we can do a time trend. I would assume with enough time that you can see that it goes down and up and down. So there's something hidden
Yes.
within this, this our frequency hopper that is not perfect, but I'm not going into that detail. Cancel that one. And we do a little bit shorter. And as I said from the beginning, sample rate, you don't have to care about sample rate. You can put that down to whatever you want. And of course it should. So this is another way to look at it. We can actually have a little bit more data. I should do single shot instead. Single. Oh, sorry for that trigger. So now we have like 2 seconds of data. Which this is hard. So this gives you another kind of idea what is happening with the frequency hopper. It's kind of goes up and down. Do you see that, there's a little
Yeah,
bit
there's like steps.
there's a little
Yeah.
bit steps here, and
Yes.
it's not consistent, but I think you can see it from here. It's also a display stuff, but in reality this exists, and I can prove it
Yes.
by going down like this and run it, and we just run it, run, and then I go back here and do a persistence infinite.
Okay.
So it seems that my trigger is not ultra perfect. So it seems that we need to actually go in here and redefine this little baby a little bit more.
Yep. Maybe a little bit higher. Yeah.
Yeah, and then we need to make
But
sure that we're a normal trigger.
yeah. Yes. So what is the difference between auto and normal?
So if you forget the normal trigger, if I don't get the re-triggering after a certain event, I will trigger anyway and display on screen.
Yep.
So you can see that in some of these cases, just capturing because the trigger doesn't reoccur that often.
Yeah.
You know, when you register, you get this trigger frequency counter.
Yeah.
And I think it's less than 100 hertz it will trigger. If you go to normal mode here, you can see it's like 80, 92. It's not really super stable, but that is how often this trigger occurs. If it's above, I think it's 100 hertz, you don't have to care about this auto trigger or not. But lower than that, you need to care about it because it's going to display anyway.
Yeah.
So if we go up a little bit here in time, just making sure, you can see this one. So if I go back
Yeah.
in
That's
here,
it.
that I did in the beginning, and have infinite here, you will see that there's like two different portions of this one, same as
Yeah.
this one.
It's hopping up and down
Yeah,
a little bit. Yeah.
but it seems that if you go in here more, let's zoom, yeah. So if you, what did I do now? I moved it. Oh my God. I wanted to show me like this. So these are the two different things, and they kind of, why is this happening? You know, kind of interesting to look at. Yeah, you agree?
Yeah.
So you can
Yes.
zoom into it.
I
Yeah.
fully agree. Yes.
So going back here, we put this to out. I don't know. Sure, can spectrum will be can spectrum view be calibrated? Can spectrum view be calibrated? That's a question. Think about that, Jukka. Can spectrum view be calibrated? I'm not. Can it be calibrated? Because this is not a
Calibrated how?
Yeah, but just thinking about, we have a roll of 3D, normal spectrumizers are flat. How do you compensate for return, losses?
Yes. Yeah. Yeah.
I
If you
don't.
compare that to the spectrum analyzer,
Yeah.
yes. Okay.
So what about doing a test? So if I want to do this, and let's say this is a frequency hopping radio, if you press more here, there's a mask test, and you can draw a mask here. You double click the mask and you have waveform tolerances instead, and you put it like 100 or 100 and 100. 100, 100, enter, and like 100. You can actually do tolerances tests as, let's say update mask now. It's probably not the best, but it gives you a little bit idea how to do things. And it would be nice if we could, I'm not really sure what we can trigger on. There's a lot of things we can trigger on, but maybe we can trigger on this one. We can do that later.
Yeah,
But-
because it's violating the mask.
Yeah, is it? So I have no,
Yeah,
it's failing, yeah. So,
Yes.
9, 10 fails out of 34.
so it's calculating all the waveforms and then it
Yeah,
reports the ones that are failed. So how?
Like that.
What is the ratio? Every third of something like that. Yeah.
and we can do act on event, for example, and this is mask hit, and we can stop acquisition. And you turn it off, turn it on. So now it's stopped. Every time I run it will stop whenever I have a fail.
Okay.
So if we were to determine to try to trigger on this one, how would you do that?
You mean outside the mask?
This violation over here. So let's
But now
remove.
you are triggering.
Yeah, but I was thinking about triggering on this one. So first of all, the level needs to be around here, yeah?
Yes.
And then I need the cursors to be from about, move cursor A here and move cursor B here. Ooh, it should be like 400, 390 microseconds. So instead of, I'm just on the edge now, I can do the pulse width, which should be a negative, yeah?
Yep.
And the limit should be, do we even dare to put it like, what do you think? Between 300 and 400, yeah.
Yeah, try that one. Yes.
In limit plus minus, was it 400?
Yes. 400.
400 micro, enter. Okay, let's see if we can do it. Stopped. Arming. And now we're triggering on the wrong one, are we?
Yes. Yeah.
Because we needed to move that up and up to the point. That's
Yeah, that's a tricky one because now, yeah, there is like 3 signals,
yeah.
3 steps, and you need to.
Yeah, I get it. So maybe we should do it. Oh, what I do now? Oh, I do the wrong way. Wrong way. We should probably looking at this one.
Yeah, there is something now.
Yeah, it's actually now it's gone. It's depending on my settings. But if we have it here, I'm gonna stop this one. So this is over here, and I take this move cursors A here and move cursors B here. That's like 27. Should we try
Yes.
that?
Yeah, try that one. I think that's a better one.
And it says ready.
Nothing. Yeah, now it's waiting for it, but maybe this is not the right one.
Limit.
By the way, we have 5 minutes to go, so.
Yeah. I was just curious why we don't do that. Is that because it's actually longer? No, because it's a positive.
Yes. Yeah.
What we have from the beginning, was it
27.
27? It's here now, yeah? We trigger on it. And we just need...
Yes.
I think we did it.
Yeah. Now you're triggering. Yes. Good.
So that's going to be interesting to see, because now we should have a... No, it's still not stable. You see why?
No. You are triggering.
Yeah, you see?
Yeah, but the picture is really blurry.
Yeah, but
so yeah, there is. Yeah, that one I can see. Yes. But now it stopped.
Oh yeah, I stopped it. So another thing you can look at on this one, if you go for channel 1 and spectrum views, have the magnitude versus time as well. And I usually have it as power log. And then we do a preview. Ready? Let's see if it even... Oh, no, it didn't trigger. Oh, let's trigger on the edge. Doesn't really matter. Frequency of pulse, we just trigger on the edge. Oh, this is a good one. You see what happened?
Okay. No.
I think it's that something happened with squelch. Because it should be easily triggering now, yeah?
Yeah, it should be. But my picture is so blurry that I'm not seeing. I can see your face, but. Okay, now it's getting a little bit better.
So it doesn't really want me to do this. Why? I was thinking about maybe magnitude versus time. Oh, yeah, stop harassing me. Anyway. Any more questions? Before we go into this, but so what I'm saying is that spectrum view concept allows you to focus on a frequency of interest.
Yes. So can you do that only on one channel or?
You can do that on several channels. So there's one spectrum view behind each channel. What they do share is the kind of, I showed you that prior, is the same kind of sample rate,
Yes.
because this is how it works. And I think that we don't oversell this feature, but I'm sure there's people out there who love this feature, especially if you're working with agile radios in general, or even IoT. You buy a
Yeah,
good
where you
scope.
need more channels.
Yeah. Of course, one of the drawbacks is that if you buy an 8 gig scope, you get an 8 gig max frequency, and
Yeah.
I think that's it.
But anyway, if you have 4-channel scope, you basically have 4 spectrum analyzers. And if you have 8-channel or 6-channel scope, you have 6 or 8 spectrum analyzers.
Yeah,
I think that's a powerful feature
it is.
if you think it that way. And in like an IoT, you need usually more than one channel. So here you can get it.
Yeah.
Okay.
And
Do we have any other questions?
I
I think
don't
we
know.
are. Time is up.
It was a long event. Yeah.
Yeah, I think there is. We had only 1 hour, but I think there would be more.
Yeah. So the next session will be hosted by me, Jukka, and Tad, and we're gonna confuse you about jitter. So
Yeah,
I already have some questions in mind, like if you're looking at the frequency versus